I want you to go back to where we took notes yesterday, and we're going to finish the two graphs that we started. Okay, so I want to remind you that we have 3 rules for horizontal asymptotes. Okay, we'll have horizontal asymptotes if the degree of the numerator is smaller and if the degree of the numerator is the same as the denominator. However, when the degree of the numerator is larger, that's when we get an oblique asymptote. And specifically, if it's 1 degree higher, we get a slant asymptote. Okay? So yesterday we went through this example of identifying our vertical asymptote was at x equals -1. We performed the division to get that our slant asymptote was y equals x minus 2. Okay? Well, now we need to graph those. Okay? Well, you know how to graph x equals -1 as your asymptote. So go ahead and put that on your graph. And then we need to graph the asymptote of y equals x minus 2. When did you start to learn how to graph lines that had slope? Was that like Algebra 1, pre-algebra? I don't even know anymore. But probably, for a majority of us, middle school. Okay? Hasn't changed. We have a y-intercept of -2 and a slope of 1. So the only difference is you just have to make it a dotted line. So a y-intercept of -2 and a slope of 1. If it helps, you're welcome to use some sort of a straight edge. I do have rulers available if that helps. Some people like using like their ID or something like that. But there would be the line y equals x minus 2. And I just made it a dotted line because it is an asymptote. Yes.
Is the like slope 1 because of the like 1 edge?
Mm-hmm. Whatever number is right here is your slope. Yep. Okay, now, I will tell you that one of 2 things will happen with our curve. We're either going to get 2 pieces in these 2 areas or in these 2 larger areas. Okay? We're just going to have to plug in numbers to figure it out. Okay? Before we do that, we can identify the domain. We can identify the domain. Think about it. Some of you are already writing it down. Okay. Emma, what's our domain going to be? What number do we need to exclude from our domain? Yeah, -1. Okay, because what's happening at -1? Okay, we have that vertical asymptote. So we need -1 to be excluded from our domain. Okay, it doesn't change from the problems that we did yesterday or the day before. Okay, wherever our vertical asymptote is, we have to exclude that from our domain. Guess what? I'm never going to make you do range for a slant asymptote graph because it's too, and you'll see in this example, it's too funky. Okay? So now we get to pick points in to plot. And I'm trying to decide how to do this. We might come up here.
This one?
Yes.
So for the domain, wouldn't the domain also get affected by the slant asymptote?
No, because this is going to go on forever in both directions. So it's going to look strange. But if my board was infinitely big, right, it would keep going and going and going and going, following this asymptote. Okay, but we cover all the x's. Yeah. But the range gets affected, and so that's why we're not going to worry about it. Okay? So just like before, we're going to pick a couple points to the right, a couple points to the left. So since we have x equals -1, let's plug in 0 and 1. Okay. So if we plug in 0, what do we get? Yeah. And if we plug in 1, so some of you are panicking. I can't have 2 points right next to each other. You actually can. Because what's happening, kind of like you saw over here, like we have to create this sort of curve, okay? So what's happening is it's turning in between these 2 points and then approaching the 2 asymptotes. Okay, so don't panic. In the case of an oblique asymptote, if your 2 points are right next to each other with the same height, okay, sometimes that's going to happen. Okay. All right, and then on the left side of -1, we can plug in -2 and -3. If we plug in -2, what are we getting? -6, I think. Because we'd have 4 minus -2 is 6 over -1.
I didn't do -2. I just did -2. Oops.
Okay, and then if we plug in -3, what? 12 over -2, right? 12 over -2. Okay, well, that's not completely surprising because we're probably going to have some sort of symmetry happening, right? So we just need to make sure there's a little bit of a turnaround in between those 2, and then we approach the asymptotes. Okay, do you see why I'm not going to ask you to find the range? Okay, our range is not going to be all real numbers in this case. There's this gap right here. But we don't have the tools to figure out where that is turning around and what height it's turning around at. So we are not going to worry about it, okay? So you get a freebie, okay? I'm not going to ask you to find the range of a graph with a slant asymptote. Okay. All right. Questions? Clarifications? Really, nothing's changed. We just have to plot our asymptote with a slope and y-intercept. Okay, that's really the only difference. Okay. So let's go to the second example we did yesterday. Okay. Remember, we factored out an x, and so we determined there was going to be a hole at x equals 2. And then after we simplified, we figured out where our vertical asymptote and slant asymptote would be. So we have a vertical asymptote at x equals -2. Okay. Our slant asymptote is y equals x plus 1. Well, that is a y-intercept of 2 and a slope of 1. So I'm going to go ahead and draw that line. Like I said, if you want to use some sort of a straight edge to help you, that's fine. Okay, but that would be where our asymptote would be. All right, let's talk about our XY coordinates. I want to remind you to plug into the simplified version. A lot of us have been trying to go back to the original, which is not a problem until you get to the whole. But it's a lot easier to do it when it's the simplified version. It's just less to think about, okay? So if our vertical asymptote is at -2, I would like you to plug in -1 and 0, as well as -3 and -4. Okay, go ahead and plug in those numbers. Don't plot them yet. Please just plug them in and see if you and your pod mates agree. So plug into the simplified version over here. Compare your outputs. Okay, what do we get for -1? 0? What do we get for 0? 3/2. -3? 0?
I got 4 and 4 but I think that's probably wrong because I did the math.
For -3? For -3, this would be 9.
Minus
Minus
12. I
12.
added 12.
Yep. And then -4. -3/2. Okay, and remember what's happening at 0? We have a hole. So we can plot the coordinates -1, 0, and 0, 3/2. We need to put a hole there. Okay? And then since it's in this space, okay, we just need to make sure we follow the asymptotes. Okay? And then -3, 0, and -4, -3/2. We just need to make sure we follow the asymptotes. Looks pretty funky, right? Okay. I am never going to make you identify the range of one of these graphs with a slant asymptote, but do not forget that your domain is affected by both the vertical asymptote and the hole. Both of them make our original denominator 0, and so you must exclude them from your domain. -2 is where our asymptote falls. 0 is where our hole is. So both have to be excluded from our domain.